This is basic information on the application and installation of an external wall insulation system. Well-insulated facades are an important building block in order to ease the burden on the environment and to reduce energy costs. A trained specialist tradesman is a prerequisite for thermal insulation of a high quality. This video shows the single steps that need to be carried out when applying and installing an external wall insulation system. In the plinth area, a thick bitumen coating is applied to the masonry as a vertical building waterproofing layer and is then troweled off with a toothed trowel. The plinth insulation board, which is beveled at the bottom, is applied to the thick bitumen coating and then aligned using a spirit level. A fillet is created in the bitumen coating for better drainage. Usually, this is done using an empty bottle. The exact position of the seal bead is first marked. Then a straight line is drawn with a pencil with the aid of the spirit level. In order to seal the connection joint, the joint sealing tape is applied to the upstand profile of the windowsill, flush with the insulation board connection. The joint sealing tape should not be put under tension when being applied, as it still needs to be able to expand. The seal bead is placed on the joint sealing tape of the upstand profile and the protective film is removed from the adhesive tape. The seal bead can then be firmly affixed along the previously marked line. With this seal bead, a permanent sealing of connection joints is ensured. This is the correct positioning of the seal beads. Now the position of the joint sealing tape underneath the windowsill is marked. The joint sealing tape is then applied along this marking. What's extremely important is that the joint sealing tape may not be stretched when being applied to and around the edges, as otherwise it cannot expand. This could result in moisture penetrating the insulation system. The joint sealing tape must therefore be applied to and around the edges in a compressed way. Now the PU adhesive foam must be applied to the insulation board. Gloves and safety goggles must be worn when working with PU adhesive foam. The surrounding adhesive foam bead is applied close to the edge and must also be applied to the insulation board in the shape of an enclosed M or W. Depending on the system, the insulation boards can also be bonded using conventional bonding adhesives. Here too, at least 40% of the entire surface must be covered with adhesive. However, this method requires significantly more time than when using PU foam. A contact surface between the wall and the board of at least 40% must be ensured. The insulation boards bonded with PU adhesive foam may not be hammered to the wall. The insulation boards are laid perpendicularly from bottom to top, tight butted in the bond and offset to the building corners. Crosswise joints are strictly to be avoided. With a hot wire cutting device, the insulation boards are cut to size, accurate to the millimeter, and are then installed and fitted. The recesses for the upstand profiles are created with a special plane. An insulation segment is fitted and adjusted to the windowsill. After approximately 10 minutes, the insulation boards must be checked again using a long spirit level, and possibly they must be readjusted. The insulation boards may not be laid and bonded in the same alignment as building corners. This means that board joints are to be avoided in the area of building corners. Here, the insulation board is notched. Exact cutting to size of the insulation boards saves grinding at a later point. For makeshift fixing of single insulation boards, for instance over building apertures, the insulation boards can temporarily be fixed with clamps. Open joints measuring up to 5 mm in width may only be closed and sealed with an appropriate filler foam. This prevents cracks and markings on the top coat. Excess and protruding material is removed with a cutter. Insulation board offsets are planed by machine using an EWIS board grinder or manually with an EWIS emery board. It is mandatory to remove the grinding dust from the facade. In order to avoid dowel pattern staining, the use of thermodowels is recommended. First, the hole for the dowel is pre-drilled in a sufficient anchorage depth. The thermally decoupled thermodowel is inserted into the insulant by machine. The application tool determines the exact drilling depth. There is no unpleasant milling dust as the insulation material is compressed. Finally, the polystyrene cap is inserted into the dowel disc recess. This avoids subsequent marking on the facade due to the dowels. Special installation elements need to be mounted for fixing the building elements onto the external wall insulation system. At first, a corresponding cutout must be milled or cut into the insulation board. Then, a dispersion adhesive must be applied to the cutout and the installation element must be inserted. This way, building elements such as mailboxes, lamps, railings, shutters, etc. can later be fixed to the external wall insulation system in an uncomplicated manner. There are installation elements appropriate for every building element. For efficient covering of the window area, the masking film is simply applied to the self-adhesive strip of the seal bead. After 2 hours, the boards can already be overworked as described in the following. The reinforcing compound is applied to the reveal and the mesh angle bead is pressed into the reinforcing compound with a corner trowel. The mesh of the seal bead is embedded into the reinforcing compound together with the mesh of the mesh angle beads. In case of a connection to an attic cover, as in our example here, a parapet profile with an integrated glass fiber mesh is applied. This prevents render from potentially breaking off the parapet sheet cover at a later point. The penetration of moisture into the insulation system is thus also excluded. In order to ensure thermal bridge-free edge formation in case of recessed plinth insulation, as well as directed drainage of rainwater, the plinth profile is attached using the reinforcing compound. A plinth profile connector, which can be cut to size as needed, is used to connect the plinth profile segments. The connector cutouts should be at least as long as the visible width of the plinth profile underside. The integrated glass fiber mesh must overlap by 10 cm in the joint area. The profile also serves to protect the plinth edge against impact loads. The reinforcing compound is applied to the entire surface. The glass fiber mesh is now embedded into the reinforcing compound while the latter is still moist. Here too, the mesh strips must overlap by at least 10 cm. It's important that the reinforcing compound entirely covers the glass fiber mesh. The glass fiber mesh is cut along the edges with a sharp cutter at an angle of 45 degrees. If necessary, the surface can be smoothed again. Finally, the reinforcing compound is also applied to the plinth, and the reinforcing mesh is subsequently embedded into it. In a last step, the finishing render is applied and textured. A silicone resin render is recommended here. Once the top coat is dry, the protective film on the windows and window sills, as well as the brim of the seal bead, can be removed. In the plinth area, an organic moisture protection agent must be applied before the top coat. Once the primer has then been applied, the finishing render is applied and textured.